And the questions, I'll be answering the questions, like typing the questions, answering them if I need to. So.
Hey guys, welcome to our Fronius webinar about third-party monitoring and control of Fronius inverters via Sunspec RS485 and TCP IP interfaces. My name is Dimi from Fronius Australia. Glad to host this webinar. Bear with me a little bit. It is a bit of a longer session, I guess. There's a lot of content to cover, so be patient, I guess. Any questions or any unclarities, feel free to let me know, and I'll try to answer as much as we can. Obviously, you can ask the questions after the webinar as well, and for any clarification or guidance or anything in that regard, and we can go from there. Yes, I can see a question coming. Yes, you will get the slides after the webinar, and there's additional content as well. Keep an eye, the last slide will have the resources. If you can't reach any of it, please feel free to let me know after the webinar. I'll share some more details, and yeah, we'll go from there. Okay, so today it's myself and Rod Dua, I guess the Fronius legend in a way. We'll be trying to, I guess, answer some question regarding Modbus interfacing and a bit of networking as well. And I guess let's get started. There's a bit of content to cover. Outcomes, what we want to deliver with this webinar, I guess, in a way, is how to show ways in interfacing and in doing that a successful integration with Fronius inverters regarding third-party applications, which can include control and or monitoring, as well as using common tools, how to troubleshoot and fast-track your integration as well. Going forward on the agenda, there's a bit of stuff that we'll go through, but in general, we'll discuss a bit of open interface we actually have, a bit of background on Modbus and networking as well, some common application interfacing scenarios, Modbus implementation, how we actually do it from our end, and what needs to be put in place for this to work. A bit of thought about the algorithms and how the coding or the backend needs to be run in a way. Some common test tools you could use, as well as fixed size questions and common errors you could actually have on your site. So Fronius open interfaces, as you all know, we do support open policy, and all our strategies in a way are based on that. We are a member of the Sunspec Alliance, which has over 100 manufacturers, not just inverters. There's meters, there's other stuff in there as well. We are proudly certified holders of compliance with California Rule 21. For anyone that is not aware of that, try to search it. I think it's a very interesting concept, hopefully coming across as well. But a key part of that is standard IEEE 2030.5, which is a protocol for distributed energy resources, which is basically a HTTP application protocol and RESTful infrastructure, how one can interface with endpoint devices, in this case, inverters, batteries, EVs, and so it goes. So the key point of all this is obviously the data manager card or box. This is in a way the access point to all the smartness and integration that we offer. As you all know, the data manager card or box, basically the same thing, comes with built-in network interfaces, LAN or Wi-Fi or WLAN. You can choose. Comes with built-in monitoring, which does go to the inbuilt Solweb web server. It does come in a what we call a multifunction card as well. So it's a data logger. You can have power control function, energy management function, as well as energy reporting in one device. I'm sure we're all aware of that. It does enable, in a way, how to do third-party integration with the Fronius solar system, in a way you put it. That can be via push service, API, or Modbus. Key point is that push and APIs generally support only monitoring, and Modbus protocols can support monitoring control. We'll go over this in a second, but just a key point to point out. So we'll touch a little bit on the push service allocated here. So in a way, as you all know, this is file push to a third-party service. You have two options there, FTP or HTTP post protocol. One common, I guess, application is the PV output software that everyone uses. On the screen, you can see some typical settings. Obviously, for more information, feel free to go to pvoutput.org, I believe it's called, but you can Google it, it will come up straight away. Any questions on this, you can obviously let me know. Background a bit on APIs. I do want to say that we actually support 2 versions of APIs, so Fronius Solar API, and you'll see later some other sort of APIs as well. So Fronius Solar APIs are free. Documentation is available there. That's a link that will take you to the actual PDF document. So that supports a JSON file transfer. The way you do it, you actually put in HTTP request in the browser. I'm sorry, just a brief interruption. Can anyone hear me well, or you have problems with the sound there? If you can maybe quickly sound, yeah. All right, someone said no sound, maybe check on your end, I guess. I'll continue onwards. It's important with this sort of access point, these are just local, again, free, and which means that there's no server integration for these sort of options. Some ways how you can use it are pasted on there, so you need to know the IP of data manager, card or box, and then you can submit any query and get some more system details. So example, I guess, query and response is on the left and on the right there as well. You're more than welcome to play around with it if you do have a system. If not, let us know. This is monitoring only, important to point out. Something we've been working on quite eagerly as well, Sol Web Query APIs. So this will be direct integration with Sol.web, which is our database. Key point to take away here is that Sol is sort of final draft stage. We should be finally available about July, August 2020. It is application to application interface in a way, so that's key point to understand there when you want to integrate and things like that. It does work on JSON, so HTTP protocol. At the moment, it's still only monitoring. You can always get more information and documentation of this, obviously, on request. Just let us know. We'll share all the information that's available. You will need to be authenticated to access any hit points or endpoints on there, which will generate an ID and a value for you. Obviously, again, directly from the database, so a bit of understanding there depends on your application, how much you use it. There'll be a bit of loading, which means if the data is getting too much in a way, there might be cost associated with that. However, you're more than welcome to give us a hit, I guess. We'll go over the documentation, explain it more, and have a look at how the costing comes into play. You can, there's an example endpoint there. You could use that. It's freely accessible. It will give you a JSON response on what the version at the moment is. So that was a quick overview of the open interfaces. Let's delve in a little bit on Modbus background and what it means. Interesting slides here. Modbus has been around quite a bit. Originally brought from Schneider Electric 79, so it's a serial communication protocol. Key point to understand with Modbus, it's a request response communication protocol between devices. Depends how the protocols interface. You can have Modbus of Rs485, Ethernet, even Bluetooth, or depends on the actual application. But the key point to understand is it's dwelling on the application layer. So Modbus RTU, you have Modbus TCP varieties, Modbus over UDP, Modbus Plus, Sunspec Modbus. So there's a few things that can be present. Key point there on the right side, you will see the actual key difference. So the red points out the Modbus RTU or Modbus of Rs485. The blue one only points out Modbus over TCP. See the keynote in the communication stack is there. With the RTU, you need to take into account the whole lot there in a way. So it's 485 physical protocols and how it all works in the back end, I guess. The blue one only handles, I guess, Modbus over TCP, and the whole TCP IP infrastructure is being handled by Ethernet and TCP IP protocol levels as well. Let's not get into too much details there, but key point, again, as I pointed out, it's the request response infrastructure. So the way Modbus is intended, you need to request a data resource or something. You'll get a response, and that response will be either response to what you requested represented via function code, or you'll get an exception response if the slave couldn't follow what you're doing, or you get a timeout. On the right side, you'll actually see implementation of that and how that works. in terms of the normal request and exception. And I guess key takeaway is that what Modbus refers to as application data units can be different from what you use in a protocol. So for example, RS485 is one, TCP IP is different. You will see in a moment how it all differs, but key note to understand Modbus is not TCP IP or not RS485, it's Modbus implemented over something. The data infrastructure is typically shown here. So you have a request and then you request something. So you either request a holding registers, input, and so it goes. Depends on data model implemented. I won't be holding too much onto this slide. The whole point here is to try to understand the timing that the protocol has implemented. So in a way, you have a master or a client in TCP. You initiate a request. There's a little bit of time for that. The request hits a slave or multiple slave, they process that request and they respond. Take away from this in what will happen if I have multiple requests or multiple responses. Just something to think about when you actually do the request situation. RS485, this is the actual wording is EIA or TIA 485. It's pretty old protocol actually, 85 I guess, or it's a relativistic there. It's a balanced pair, so it's pretty noise immune. So it's still used today just for that reasons. It's not that quick, so by default comes with 2.6 and 90 kilobits a second. Some typical implementation is shown on the right. This is coming from the protocol itself. The key point is that it's typically we use the two-pair topology, two-pair bus obviously. Then you actually have 4 communication lines there, so you have a plus, minus, a common, and a shield. Technically, that's 3, but yeah, don't forget the shield in a way as well. Shield is only connected at one point through it, keynote, as well as the comms line is to be connected usually at the master, as well as every point, obviously. Balancing pair means that you have to have the 120 ohm resistors at the start and the end of the comms channel there. Why? Well, it does help suppress data reflection a little bit on the comms line. More than that, it's actually not really that important. Sorry, just a few questions there. So yes, TCP IP can be over Wi-Fi. That's correct. We'll go over that in a second, but yes.
I'm answering it in the background.
So Modbus of RS485, a little bit is different from TCP. The difference is basically you have master slave topology, one master and up to 247 slaves. You could have everyone, specifically slaves, need to have unique addresses, and you as a master address slave responds, or you either get a, I guess, exception response. So again, protocol defines the master must request, slaves must accept and respond. If they can, obviously. I guess, interesting question. Can I have multiple masters? We'll answer this later as we go, but just something to think about. On the right, you have 2 request modes typically defined. You have unicast, which means you address one slave if you want to request information or tell the slave to do something, or you can have broadcasting mode, in which case you address all the slave in one go in the same package. I don't want to bug you too much with the details background. Too much. The main reason about this slide here is how Modbus actually interface over RS485. The keynote is there, the PDU, so how the protocol data unit is interfaced, and the gaps in between. So whenever you have bytes coming in over the RS485 line and you want to send multiple messages, there will be gaps in between. So the driver and slave realize who's ending, who's starting to speak. A lot of times we have questions about, can we integrate over Wi-Fi? Can we integrate other media? You can. You need to start think of how would that interface the gaps in between the bytes and the frames. For example, if there's no gaps in between, or if the gap is too long is usually not an issue unless you split individual bytes, then the actual slave and the master will discard the frames. I don't want to go too much into it. The whole point is that if you start introducing delays into the whole concept, you might start thinking chopping and slicing the frames, and you may end up in a situation when you can't differ frames from one each other, or when you start chopping frames unnecessarily. So when there's a Modbus problem, just think a little bit. It might be a comms issue in the implementation itself. So TCP over Ethernet. I'm showing LAN pinout on the right side there, but you can implement Modbus over Ethernet. So that's IEEE 802 series, 803 and 11. So LAN and Wi-Fi or WLAN, you can interface both with us as well. A bit of a thinking pattern there. If you have it on Wi-Fi, a bit of noise, how would that influence the whole lot? But I guess that's pretty much it. So over Ethernet, it's RJ45, 100 megabits is the speed used. The pinout is listed on the right, which is very typical, straight through connection, nothing really out of the ordinary there. A bit of the software background on Modbus over TCP IPs. So one thing to take away from, I guess, this slide is that you have something called the Mbap Header, which is typically implemented for Modbus over Ethernet, Modbus TCP IP over Ethernet, obviously. It's done on a pre-dedicated port or socket in a way, 502. You could change that, but we'll go over in a way how that can change things. And you also have slave IDs there. Now, with RS485, this is mandatory. With TCP IP, depends on application, may or may not be, but for us, we'll always use it. A bit of more, I guess, dissection, how this all looks on the right there. You're more than welcome to delve in more details there. So I'll go in a bit more details on maybe some common interfacing scenarios, maybe not all of them, but let's say what we've commonly seen, and then this should maybe start answering a bit of those questions. How do I interface? What's the best way forward and things like that. So as we said previously, data manager card or box is required for all interfacing. In a way, the card, from our point of view, we have 3 comms channels. So the SOLNet loop, as you know, or RS482, RS485, so that's what we use to interface data manager card or box to a meter, Fronius meter, or TCP, LAN or W9, doesn't matter. But key point to take away there is that SOLNet is only used internally for our inverters. In a way, data manager card is your access point. It can interface to third-party PLC, controller, or logger. That in this case is shown is over Ethernet, in which case you could use the RS485 channel to use a Fronius smart meter and monitor consumption. The next slide will go a bit how this differs between 485 and Ethernet. The key difference there is that once you start using the RS485 channel for external monitoring or control, then that channel becomes busy for using it from our point of view for getting consumption. So it's actually not possible. Something to think about when you want to do your implementation. On the right side, you'll see a typical, let's say, master-slave configuration, 3 inverters, a card, and RS485 implementation with a third-party PLC, which is a master. We always slave in this situation. On the left side, we'll have a typical implementation, I'd say, with Modbus over TCP IP. Difference is Modbus channel is free to communicate with the meter, and then you communicate via the LAN or the WLAN, I guess socket in a way, or interface. I've tried to do a bit of animation there. I did miss a bit, so I do apologize for that. So I want to show what's the, I guess, power of Modbus TCP integration and how that's good, can be better. So let's say in this case, we have 2 systems. System number 1, we have a master-slave situation. We also have a Fronius smart meter there. So a card speaks with slaves over SOLNet loop, which are the inverters. Over 485, we speak to our meter. Then we have a Ethernet on site and a control that interfaces to the card via Ethernet, your normal TCP IP in a way. Then we have a second system, let's say, which is connected via a different card. You might have a third or fourth or fifth. It will be absolutely the same. The difference there is now just if we try to separate those systems, so we have system 1 and 2. Let's add another logger. This is also possible. You can increase the number of loggers as well. In terms of the cards, you don't necessarily have to use the cards. You can use cards and or boxes. This depends what's best for your application. And you can also have internet there as well with Modbus TCP integration. One challenge you will have is the actual timeline. For example, if you want to have multiple monitoring, multiple control, which one is become first? If data, I've shared with the slide previously, if one client wants the data first, how much data it wants, how long it will take. So just something to think about when you implement multiple, I guess, requests in a way. Okay, let's delve in a bit in the actual Modbus implementation with Fronius. So as you all know, the Fronius Modbus models we use are based on Sunspec. More information you can find on the official website. We do have official guide. There's a hyperlink attached to the link there. So it's called Fronius RTU and TCP guide. At the end, we also have the resources as well. Key point to take away there is that in terms of implementation, we implement a 16-bit holding registers in terms of data blocks, predefined, which you'll see later. When you have some registers can have bigger values, so maybe 32-bit, 64, so it goes, which means you need to read multiple registers. As I mentioned previously, you can choose either between RTU or TCP IP, which is in a way 485 or Ethernet connection or data pooling. Again, this is a master-slave infrastructure. This is based on RS485 or client server. This is based on Ethernet TCP IP. Again, request responses. When you request for something, you're going to get response from the slave or the inverter in a way. It can be a normal response. It can be an error, in which case you can end up in a timeout. It can be a slave processing error. Something happened on the backend, in which case you'll get an exception. Or when you do a broadcast, you will get no responses. It's important to realize that when broadcast is being used, slaves will not respond by default. This is the way the protocol is integrated. Going forward, so in terms of Sunspec compliance, we've implemented the models shown there, as well as the controls. I'll share the information below as we go, but you can delve inside the register, see what the representative values they bring. Key note to think about: response times. When you submit a request, how long it will take for an actual device to respond. Depends on the length, depends on devices. Obviously, that's a variable, can be up to 10 seconds, 5-10 seconds, possibly even more. Something to, I guess, think about while you do the integration. Also, important thing is that simultaneous requests are not allowed. You have to do sequential queries. This is a bit connected with the previous case where I said you have multiple loggers or controls on the line. So you need to start thinking about if you do have, I would say, multiple masters in a way. It's not master, but clients, which one has a priority and which one can be excused, or maybe a bit of time in between is being allocated. Important thing to realize, when you assign Modbus ID addresses, there's actually two ways to look at it: in the solar net channel and RS485 channel. The solar net is the inverters being installed in a way, which is the inverter number. So you'll get numbers here from 01 to 02. So it goes, if you get 00, that will become 100, actually, just for information. The meters, we've implemented them in an interesting way. To access the meters, you obviously give the meter an ID. 1, 2, 3, or 4 once you do it on RS485 channel. But to see the meter externally from third-party device, you would need to use 240 as a prefix. For example, meter number 1 becomes on the RS485 channel from Fronius becomes a slave with ID 240 exposed to outside to you as a third-party integrator. So with ID 2 becomes 241, and so we go. I won't comment too much on this slide. This is more for your information. This is how the TCP has been implemented and what's the importance of the Mbap headers, what they represent. Sometimes we may ask for these log files when you have Modbus problems. Why do we ask for that? On the left side, you can see the logs. At the end, we also got through some common tools. You see how you can do that. But those logs bring key data, and each data means something. So this slide was generally supposed to represent the meaning of that bits and bytes. So it's not, we're not asking because we want the data. It's important for troubleshooting as well. Function codes. So as you guys all know, Modbus does come with predefined function codes that you need to use in order to do something with the data, either read or write. We support 3 typical function codes in a way. So that's 03. That's giving us hex as decimal as well. So 03, 06, and 16 in decimal. So that's read holding registers, write single or write multiple registers. It's important to realize the difference and how can that affect your application. We'll go over this a little bit more, but just to realize that's there. A bit of more information, what exception codes are there, how the requests look, what can you expect. Obviously, this is all in the documentation link that we shared previously. Settings and how to set the data managers for the actual Modbus integration. So as we said previously, we look at TCP IP and RTU RS485. With TCP IP, the window looks something like that. So you need to choose data export, how you're going to go with your model. At the moment, you chose TCP, Modbus port, 502 is by default, string control address, not important at this point. You need to use your data model you want to implement. We use integer plus scaling factors. You can also use float, depends on your application again. Additional tools you could use, you could restrict, if you want to enable control, you need to specifically say or tick the button there, I guess. If you want specifically to restrict the control to one IP address, you could also do that for additional security, and you can put it the IP address on the actual device that's going to issue the control as well. Again, interesting and important information as well. Controlling priorities. I've put this on purpose. Make sure if Modbus is your #1 priority, that set is actually #1. On the next slide, we'll see as well, but at the bottom right of the picture. This is because the internal control system will prioritize which functions will come first, and you need to choose how you go, but do you want IO control, Modbus, and so it goes. Similar situation for RTU. The settings are a bit different. Different in a way that you can choose your baud rate. 9.6 and 19.2 kilobits a second are predefined. Choose your parity. Inverter control, again, you need to set as well, and select your data model. Crawling priorities are still there as well. Again, key point to take into consideration, there's no smart meter integration, so there's no Fronius dynamic limit with this option. So as mentioned previously, something to think of when you have this situation. Alrighty, let's delve a little bit more inside Modbus and what it brings. So in this presentation, I'll be start addressing registers and values in the in integer plus scaling factors Sunspec mode. You could also use float for that. You could also use the files as shown here to see what's fitting there. Again, we're using holding registers, as mentioned previously. These are the typical models you would probably want to have a look at. There's a link there. If you use that link, you'll download an archive file. Inside there will be a spreadsheet which will contain all the mapping for the registers, what they represent, and some key information there. So I'll encourage you to download the file and play around with it a little bit more. Before we delve into registers and bits and pieces, one thing to realize is that there are common site registers. When we say common, that means that can be those registers can be addressed from any slave. So the numbers in brackets are the actual register addresses. If you put, let's say you have 10 slaves, so if you try to see the site power, 502 plus 2 registers will be same from any slave for your information. Specific inverter registers. So I've listed just a couple of the inverter registers there. The 40,000 numbers, these are the holding registers. Those are the actual addresses, which you can find registers on. So you can find AC current, voltage, power, frequency, and so it goes. Registers as listed here. One example, just to point out, remember there's a value and a scaling factor, and there's a bit of calculation you need to apply to arrive at the actual value. For example, let's read the watts at an actual inverter. So register 40,084, we read the value as shown here. Then we read the scaling factor, and we need to multiply that with the actual value, some value of the scaling factor, or divide it, if you will, which we will arrive then at our watts as measured. Key point takeaway there is that the raw values you read don't actually represent the value you may read, so you may need to apply a scaling factor, in a way divide with something. So inverter registers, how do they look like? So this is one snapshot of the table you'll find in the link shared previously. Look at this well, because there's a lot of important information here. One is the starting address of the registers, how long they are, which is pointed out in the size. Reading all writing registers. One function codes are supported, as shared previously, 3, 6, or 10. What's the name of the register? Some description there. I would point out to the inverter, to the register type. This will tell you what values you can expect there. If it's unsigned integer, 16 or 32, so it goes, and the scale factors that actually will bring you to the name of the register used for the scaling factor you need. So please keep a good check on these registers. This applies for the inverter as well as meter. There's plenty of information there. This same applies for the meter as well. Absolutely the same. I wouldn't say copy paste, but the value is a bit different, the register a bit different, but it will be similar scenario there. Now let's look at some more advanced registers. So I guess two important registers to point out here is that the operating state of the inverter or the machine in a way. This is split into two sub-registers. If you get the standard register or ST state, and then the standard vendor defined. The key difference there is that the vendor defined supports more states in a way, and they're listed as shown here. It's a bit field value, so you're going to get a match value based on where the inverter is at. And not all of them are supported as shown here, and in the value set previously. Have a look which one is supported and not when you do your application. I won't go too much into detail here, but something to be aware of. You can also read the state codes on the inverters itself when they arrive. There's two registers for this. There's event 1 and event 2 registers, which are represented in the table there. You can get more information in the Fronius state codes and event flags. That's a spreadsheet file. Multiple, spreadsheets will be part of that, in which you can open, explore, and play around with a little bit as well. One thing to be aware of, you can also read the real-time error code at the inverter. You could do that if you read out register 214, which is the common registers I haven't shared previously, at the inverter you are at the moment. So 1, 2, 3, or 5, or any inverter that's at the moment connected. Register 214 should represent the active state code that you see on the screen. Maybe you want to think of to implementing or not. This also depends. Going forward, when you do, we'll go into a bit more in control, but this is more saying about what's the status on the actual third-party control. Why am I bringing this up? Well, a lot of times when you actually do want the inverters to do something, either it could be limit watts, VARs, or power factor, you want to see if the system control took place, if it's active or not. You can do that by invoking register as listed here with address 4217. It's a binary value. You need to read the binary values of the register itself. So bit 1 to 0, 1, and 2 in a way. Each value of those bits represent the state of the machine itself. For example, if bit 0 is at 1, that means the watts are active, and so it goes. Quick question here for you, I guess. If bits 0 and 1 are set at 1, what mode is active? I mean, it's easy to deduct. That will be the watts, and the VARs are active. What does active mean? That means that third-party control has been engaged for those two modes. We'll go more in details later how to do that. Something to be aware of if control has been activated or not. So Modbus control. Let's start looking a bit on how you can actually do a Modbus control with our inverters. I still put two more status registers here because I think they're important. When you do control, you sometimes want to see if it's following or not, at least for maybe troubleshooting purposes. So I guess we, in a way, will look at a little bit on the status of the inverter, status of the control, and what are the operating modes you expect from the inverter. So there's 4 in a way. On and off, if you want to activate power feed operation, what we call, or standby, or the internal inverter disconnect. If you want to control the watts or the output power, you want to control the power factor, or you want to control the VARs, or provide constant reactive power, or get constant reactive output inverters. Let's start. Okay, so status from the inverter. So this is the register listed here. This will tell you what's the status of the machine, if it's connected or disconnected. We think it's a little bit important, especially in some cases, to see what the actual inverter is doing. This is a way how to read the status of it. Status of third-party control. I have shared this previously, just to highlight its importance. This is the exact copy of it. Basically, depends on which bit you read. If you get all zeros, that means there's no active control. If you get 1, 1, so right to left, then it will represent a state, as listed previously, and so we go. Standby control. The way to do that, it's listed, the registers listed are below what we call as a or connected register. This takes 0, 1 value. There's 2 timings registers allocated with this, which are basically coming with Sunspec. And I've given here an example. Let's say device with ID 0. It's not ID 0, it's ID 1, sorry about that. If you want to disconnect in 10 seconds and stay disconnected for 60 seconds, how can I do that? Well, the code should represent something as shown there. Remember, I'm specifying broadcasting. So in a way, ID 1 or 0 will matter. For example, if that ID was 0, that will disconnect all the slaves on that specific IP address. If that ID was 1, then it only is going to disconnect 1. It will toggle multiple register offset by using function 0x10, and we'll write those values to the registers. Output power reduction. This is probably the most important one, I would say. So there are 5 key registers to think of when we start implementing this function. They're listed here. Key note to understand here is that those percentages listed here, it comes as a scaling factor, but the values that you're going to write are from 0 to 10,000. So that's 0.01% intervals that you can change there. And the default, if you don't engage the mode or the mode lapses, it will always be 100% of the system power, of the inverter power. Remember, we say 100%, this is 100% of the inverter power itself. So if it's a 25 kilowatt, we mean 25 kilowatt. Whether actually 25 kilowatts going to come, this depends on the input. We always want to give 100%. This is how the mode works and how Sunspec defines it. So let's look at 3 examples there. Let's say the first one, you want to do 50%, you want to start straight away, stay at 50%, and I'd guess indefinitely. So there's no timings allocated to that. The appropriate command would look something like that. Again, this is writing ID 0. We'll go over this a bit later. If you want to use broadcasting, you write ID 0 there, but let's cover this as we go there. You would note that WX enable, I've used a red, I guess, font there, red color there. The reason for that is that this is using function 10 on purpose, which means that we expect this to be written in one go. The reason for that is once you write let's say the first 4 registers from the tables there, they will not get implemented unless you enable. So you write your registers and that's okay, but you need to tell the system, I want this to start now. Maybe you don't want it to start, maybe you want it to be delayed a bit. Sunspec does define this enable regardless. So make sure when you do your control, always use multiple register offset or function 0x10, and then you invoke all 5 registers in one go. This is of critical importance. Similar situation for controlling the power factor as well. It will be a block of 5 registers. I would say, if not copy paste, but very similar to one said previously. One thing to point out, you can always have positive or negative power factor, which means positive will be capacitive, negative will be inductive. Something to think of when you do your implementation. And when control lapses, if it does happen or you disable the mode, then it will always refer to default power factor setting that are at the moment, whether that's going to be a volt var kicking in, whether it's going to be power factor of 1 if it's not set. That will be default, will always be the case. VAR control, I have actually 2 slides with this one. I don't want to trouble you too much with the formula there, but I just want to point out that our inverters are capable, the bigger commercial inverters are delivering 0 to 100% of its rating in kVARs. But once you start doing VAR implementation, a bit of understanding needs to be in place on what you try to achieve on site. How many VARs you want to achieve, Do you want to fix power factor on site? You could. This is some calculation for that, but something needs to be put in place to realize what are the device on site, what do you want to offset, what will be the resultant, what will be the expected value. Some information how this works there. Next slide will show you the control as well. This is very similar to the previous two controls. You'll see in the table there I've skipped some registers. Bear no mind in those because they're not supported, or register 40249 is actually only read register. You can use function 10. You can write to all these registers. As shared previously, positive and negative values, they'll be very similar to the power factor control. And don't forget the enable component. If it's 0, then the control will be written, but won't be enabled. So let's not forget that. Before I go further, something to bear in mind, you can't have VAR and power factor control in the same time. They're mutually exclusive, so you can choose. You can either control the power factor on the device or the VARs, because they're really the same thing. It depends on what control do you want to get or expect from the device itself. Something to think when you, I guess, do your application. I'm not going to speak about, I will speak about algorithms, but I'm not going to go too much details. The reason why I have that, I guess when you do an application, whether that's for control and monitoring, a bit of thought needs to be put in place how the algorithm will function. When I say algorithm, I mean the whole code from start to finish. You want a well-structured code, a clear overview, what your reads are, what your calculations are, what your writes are, and even if you have fail-safes. Yeah, it's obvious from the picture there which code is easier to read and which algorithm would be easier to implement. So I guess a bit of, planning before any algorithm is getting implemented, whether that's going to be reading or writing or both. A bit of general advice there would be, I guess, define your goals. What is the goal, the task you want to do? How many devices you're going to control? What are the inputs? What are the outputs? Do you want any fail-safe? How are those going to get implemented? Any limitations that you might have? Possibilities is any, I guess, maybe add-ons you want to have in future for the application as well. Potential time delays as well. We'll go in this more detail, but just some general thoughts to think of as well. So I guess it's easy to visualize goals. One easy, I guess, cycle. You're going to have initialization, as stated here. You're going to read your inputs. You're going to do a calculation. You're going to do some comparison, write outputs, and do a loop again. You also need to think of what are your inputs. You're going to have multiple smart meters, multiple inverters, multiple points. How are you going to read them? Which register you're going to address? How many cycles this is going to go through? How are you going to calculate the actual values? Are you going to initialize components? Is that going to be a big key part of the application or not? And how response times can influence this whole cycle in a way. This leads us to the actual process. So once we define what we want to do, we define further our tasks. So we read from somewhere, we write to somewhere. What are limitations in reading there? How quickly I'm going to read? What are my expectations from the readouts? Am I going to miss values? Am I going to deliver, let's say, the watts and VARs readouts I have from the meter or not? Again, closely bound with the limitations you're going to have on site. Is it going to be quickly enough for your application? Do you need more speed or not? What data types can you get? What calculations you've put in place to actually get to the result you want? Are there any network limitations on firewalls, access? I guess cabling in a way comes there as well. Security, I guess, concerns, as well as data read types, and least one, but not least important, I guess. So some practical example, let's say we have a task, we want to read site production and consumption. We have a HVAC controller that's capable for Modbus, key point there. We have one Fronius smart meter on the side. We have 10 inverters, one master. So this means one data magic card. So one master and 9 slaves. We want to read the 3-phase value from the meter and calculate the output. How to do that? Well, we need to invoke Modbus Strings function, which is function 10, from IP address where the meter is installed. What's my ID I'm going to read? As we said previously, it's going to be 240 IDs, one at the meter. How many times I can do that? Do I have to cycle 2 or once? one thing to understand there, 03 reports with read. So let me go back. 0x3 can support multiple registers read in one go. So you may not necessarily need to read cycle 2 times, but something to think of. What register you're going to get the production from? Okay, there's 2 registers there per inverter. Okay, I need to calculate my output and I need to display it somewhere and show it. Example, here's some values and how we can arrive at our destination, I guess. So another task, let's say I want to just read the site production. I have a PLC, I'll have multiple inverters. I'll have 4 access points there. They're split in, say, 4 IPs, so 4 data managers, 46 layers, 4 masters. Task would be roughly the same. Read 3-phase value from meter. This is actually from inverter, my bad. And then calculate the output, maybe summarize. Depends what it works. So in your case, you're going to have the similar situation, function read holding register function. Now you have 4 IP addresses, so you have to read 4 different registers, 2 different registers per address, and then this calculate that, let's say, resultant value, and what's missing there, display it somewhere or put the data somewhere. So what possible limitations you can actually deal with when actually doing sort of these tasks in a way? Well, one is the poll rate. How quickly do you want to read? Is this going to be per second, every second, 5 seconds, 15 seconds? Will your slave respond before you initiate another slave? You have to understand, as we mentioned previously, maybe a slave is a bit too slow at the moment, maybe it didn't understand. Maybe we'll throw an exception. Will that throw the code off balance? Has that been thought of? Do you want a second request there or not? Is the data valid that's coming? Sometimes you might get, I guess, different values or unexpected values in a way. Remember, we do support specific data types as listed previously. There's a table listed here as well. You can find this in our documentation as well. Key point is that, I guess, is it a assigned integer, unsigned integer, and I guess so it goes. Are there any software limitations? Can the PLC, can the logger handle the data? Is it going quickly enough? Is the data getting addressed somewhere? So it goes. There's also network limitations, but we'll go into more detail a bit later. Expected behavior. I'll speak about this a bit more, I guess, but why I'm talking about expected behavior? Well, network integration always seems to have the least importance from our point of view, and this is actually important in a way because networks can present unique challenges. They can cause a lot of noise, errors, disconnections, integrations. So a bit of thought needs to be put into that in the application as well. Again, what kind of errors can occur? Are we catching? Do we need to catch any errors? Are they in the Modbus? Are they in the network? Are they in the data profiles itself? Something to think about as well. How can we improve? That's key point as well. What we can suggest going forward, always use, when you want to read registers, always try to read multiple registers in one go. So 0x3 can support that. Also, a way to think of is when you do apply application, what happens if you miss the data? You're going to want to retry again? Are you going to wait more? Are you waiting sufficiently? Does that time need to change? Am I doing monitor and control in the same time? Again, just trying to portray the general challenge of that algorithm that has to be put in place. I'm sharing here, we've shared previously, but this is a bit of a response from a client master server communication over TCP. What you can send a request, how quickly do you respond? So a lot of information can be gathered from this log file. I'll show you how to do that, but timing, addresses, registers, data values, exceptions can all be troubleshooted through a simple log file. We've spoken about monitoring. Let's think about control and how that can be, how those tasks can be implemented. So let's hit a specific control. Let's say we have a site, we have a PLC controller, which is Modbus capable. There's also site meter, and we would like to control the, let's say, export on site. Let's say the site has 45 inverters. So there's 3 data logger IDs, which means there's 3 master inverters, and the rest are slaves. In a way, if you think about this 3 solenoid rings. So what do we want? We want to read something, calculate something, and write something. So we want to read the site power, it's the input. So we want to calculate what the site is doing. We need to put some sort of algorithm in place or some calculation to calculate the level we want to get to or we expect from the inverters, and then tell the inverters to do exactly that. A bit of refresher, this is the what control mode we've covered previously. The registers as shown previously are looking at that. So don't forget, we need to write these registers to achieve our function. A bit more into detail on how this can be done. When we say read, okay, well, we actually read three-phase power value from a meter. Meter is located on a IP address. We want to use some function to read from the meter, which has a specific ID. We may want to cycle it more times. Remember, if you want to get more data, you either going to get in one go, or you have to do multiple cycles there to get all the data. Then you may need to do a little bit of calculation to arrive at the actual watts. Calculation bit, I'm not going to go too much into this detail. This can be site specific, but a little bit to think of is what is my installed capacity? What's my capacity at the moment? What's my feedback loop? Is there any feedback loop? We do want to do PID, PD control, load fluctuation considerations. Side loads can change if you do maintain a zero export. How is this, I guess, occurring in combination with solar generation as well as the load itself? Writing, this is probably the most interesting bit. So let's look at three cases. They're all equally important, and all the stuff I've communicated previously, they will play critical, I'd say, part of what the limitation on the site will be. So let's say case one. So let's say I'm going to use broadcasting. I'm going to use functional multiple register offset. As I said, I have three data logger ID or three IP addresses that I want to address. I'm going to use multiple register offset ID. That's a typo there. That's ID 0. So I'm going to use broadcasting functions 010. I want to get to 50% timings. I'll put zeros just to make it easy. I want to enable. How quickly do I need to do that? Well, it's actually 3 cycles from the controller. Each IP supports 1. It's done in 1 quick swoop. It's going to take, I would say, half a second, probably not even that. Now, let's say case 2. Your controller doesn't support broadcast. You don't have that function available, but you do support multi-register offset. That means that you need to address every slave individually. This is still not too bad situation to think about in a way, because you still have to address all the IP addresses, but you do need to cycle all the slave inside each IP address. As we said previously, there'll be 15 each, so those IP addresses will need to change from 1 to 15, and each will need to receive all these, let's say, the function to go to the desired state. In this case, 5,000 or 50%. Enable as well. So as I said, repeat for all these 15%. In total, you'll probably look at 45 cycles there. Remember, I'm talking about the write cycles, not read cycles, only how to write. Case number 3, maybe the worst case scenario. Let's say you can't support Modbus and you want to write single register values. This is the most challenging one, because as you can understand, there's 5 registers to think of on each slave, and we have 45 slaves. So that's exactly 225 cycles you need to go through to write one value. What if you want to have these cycles you want to change at 5 or 10 second intervals? That will become a challenge. You'll see in the next slide. We'll talk about some timings there as well. So the key information, think about when you do control, think about the application you want to do. Think about the outcomes you want to get. What's the best approach to go with for your applications? What can be pros, what can be cons? Not every, I guess, situation is ideal. Some are good, some are bad. What can be, I guess, the good and bad sides in every situation? Critically important is time considerations. I'm assuming 5-second delay. So for the cases I've shared previously, you would probably need last looping time is about 1100 seconds. The case in the middle is about 200 seconds. And the first case, you probably take no delay of, let's say, 5 seconds. So see how this is just the write cycle, how quickly this changed on depending on how we decided to apply to integrate our application. As I said, key considerations are important, and how to best apply the application can, in a way, make or break a code. What I want to point out there is that when you actually do a control, a lot of things can interfere with the actual writing cycles as well. For example, do you want to think about whether the feedback is implemented or not when you write the system to go somewhere? Do you want to check if that actually happened or not? So some sequences, have they been put in place? Do they, or is it important for them to be in place? For example, with inverter number 5, is it important to actually look at every number inverter, every slave or not? Some situation that can occur is oscillations. So this can happen with typically bigger generation whenever load can match it. So how you will handle, because people, I've seen responses in thinking of it's actually the control not responding properly. Is it, or is it the load is actually not the load control feedback in a way is not implemented properly? Maybe a little more thought needs to be put into that. Just an idea there. Is there only volt var put into place? For example, is volt var curve will always take priority over external control? So if you want to do external control and you want to get volt var, you might get a bit of interference there, a bit of opinion on that. And if you do have individual errors, how that's been handled. For example, some slaves can end up in an error, maybe an at fault, and any error whatsoever. How is that taken into account? Just something to think about, I guess, when control is getting implemented. So common test tools. This is actually a very important bit, because using the same tools all over, it's important. Every application is different. We're not going to go over every possible tool, but we will go over 2 tools that are free for you to use and to deploy, I guess, in a way. The first one is Schneider tester tool. Why this tool? Well, maybe because in a way that Schneider did invent Modbus quite a bit, and this tool does offer some unique, I guess, capabilities. It's pretty simple. It's a run-on tool. You can pull up to 10 registers, unfortunately. You can write as well. The key information to take away from this one, it can calculate the error counts that came into place, but it also measures what's the transaction time that has occurred. This is the request to slave and response, and what was the maximum received. This can be used for troubleshooting purposes, just to see how your application is polling on site as well. The second one, I've shared some slides of this tool previously, which is the log files from bus monitor. It's also a good tool as well. Key information, a lot of controllers and a lot of tools do have -1 embedded offset in the addresses. So the actual addresses you get, you actually need to offset -1, which comes to the actual starting address. Something to keep in mind. You can, this tool, the uniqueness about this tool, you can pull up to 200 registers in one go, and you can see the actual log files, how the request came and how the request went on and how the response came. And you can actually troubleshoot quite a fair bit based on those logs there. Okay, there's a few questions that came, we'll address them, I guess, as we go, but some key errors and I guess frequency questions we've seen, I will try to address them a bit here. So relevant documentation, I've shared a link of this previously, which will be found at the end of the slides as well. But our key document is the Fronius data manager Modbus TCP and RTU. That's our internal Fronius information there. But that needs to be used in conjunction with your application. So please read it, dissect it, and I guess give us a contact us if you need clarification or maybe have some questions about that. Can register be changed or choose a different mapping? Unfortunately, no. This is because Sunspec has defined those 2 data protocols. As I said previously, there will be the float and integer plus scaling factors. So you have to choose from which one do you want. This is an interesting one. Can I have simultaneous third-party logging and solo web? It's a yes. I'll go back in a bit why that is yes. There's an asterisk there. Why that is. Can RTU 485 third-party control be used with a meter? No. We explain why not. Because the the Fronius meters speak on RS485 channel. Well, we're actually using that for the control or monitoring. Depends how you use it. So you actually can't have them both. Now I'm gonna I'd like to address the question: can you have multiple masters on RS485? You actually can't have that because that will introduce. It's not meant for that, because if you have multiple masters, first of all, whenever either of the masters is busy, that will render the channel useless. Plus, the slaves will be confused in a way where and when to respond. So it's definitely not less than ideal situation, I guess. Third-party monitoring with Fronius dynamic limits. Yes, this is possible. Again, this is only possible with Modbus TCP integration, and as listed previously, priorities need to be set in place on which one comes first. Let's go back to the questions. Simultaneous third-party logging in SolWeb and multiple third-party loggers onto the system. These are somewhat related questions. The answer is yes, you can have multiple, but I guess follow-up question would be, what has higher priority? Because whenever devices are getting pulled from multiple, more than 1, 2, 3, or more than 5, let's say loggers, if the data request is substantial, remember, slaves will be busy responding to the initial request before they take the second request. So when you start implementing this third-party control and logic, a bit of thought needs to be put in place. What comes first? How long will it take? And how will that interface with my data? It's possible, but if you would like to get 200 registers responses, well, and you want to do it per individual inverter, that will take a while, which means that interfacing with someone else, something is going to get a timeout, because it will be a lot of registers to I guess address in a way. But yes, I guess I'd like to boil down. Timing needs to be, I guess, thought about a little bit, how that will function with the application itself and whether that can be adjusted. So going further. Okay, so typical issues. Let me go back a slide. Apologies. I've jumped a slide. My computer didn't listen to me a little bit. Apologies for that. So some I guess general meter questions that can be related with the actual applications as well. Can meter registers be written on? They can't. They only read only, and the accuracy is 1, class 1, or which 1%. This is the power accuracy we're talking about. More information, you're more than welcome to contact us. More than happy to share, obviously. Can you have multiple meters? Yes, you can. Bear in mind that in regards to third-party integration monitoring, you will have to go with Modbus TCP, because RS485 channel will be busy or dedicated for the actual meters itself. The moment we support up to 4 meters, when you allocate IDs, as stated previously, there'll be ID 1, 2, and 3 on the meter itself. Under the actual interfacing, you'll find this under 240, and incrementally it will change. For example, meter with ID 1 will be 240, ID 2 will be 241, and so it goes. A lot of this, I guess, a good question as well, estimate response times. Now, to answer the question, we really need to understand how the application and how the system looks like. How many devices will be connected? Are there third-party meters? How that, I guess, interfacing will be oriented. Just a quick rule of thumb, I guess, meters, you can also expect 1 to 2 seconds delay, and inverters 5 to 10 seconds. This is a bit on the high side. The more inverter, the longer it will take. The less inverters, this will be quicker. The reason why I have this here, this can also affect your application. If you want quicker response times, well, then maybe just reduce the number of, increase more data managers. For example, if you have 50 inverters, you want quicker times, maybe 4 or 5 data manager cards can satisfy your timing needs. In this situation, bear in mind, only one of those will have meter connected. You don't have to have meter connected across all of them for the data to show properly on SolarWeb. Some common issues that we've seen, I guess the critical one is that we hear is Modbus doesn't work. The reason I've bolded that, please bear in mind that we would like to know more information when we hear Modbus doesn't work. What is it that doesn't work? Is it the connection that doesn't work? Is it a networking issue? Can you ping the IP address? Is it a firewall that interfacing in between? Is the Modbus enabled actually? Is it on port 502? Is it on some other port? Very quick information there. If you want to choose another port, please read this document. It's from IANA. This is defining why Modbus in 502 and why having a different port can influence with the network. I won't go into too much detail. It's important to realize that. A quick trick, I'd guess, this is Chrome. One easy way to see if you have networking without any tools. If you try to put the IP address on the actual data manager card, you can see it on top and use :502 port. It will respond and it will say not working, but then at the bottom will say what's the response, why is it not working. In this particular instance, you'll see invalid HTTP response. This makes sense because it's actually Modbus over TCP, it's not HTTP, so the browser doesn't understand Modbus, but this is telling me that the comms is actually working, so there's something positive going on there. You might need a tool to see poll data, but it's a very quick way of seeing if the connection is up or not, if to the port itself. And there's another, I guess, tips and tricks that you could do as well. Under system information, under the actual data manager interface, you can get the IP address that the system took, and you can also get the MAC addresses that it took. This can be important if you're on, I say, bigger commercial site, you have a site-specific IT restrictions, you may need a MAC address, you can find it there. And you can quickly troubleshoot your network situation. So if you put in a local IP address in the actual network diagnostic tab, it will give you the ping response on the local network. You can put Google there, for example, or solwebfronius.com. It will tell you if you actually have connection to the actual IP address. Bear in mind, this is only telling you if you have a connection. It doesn't tell you if the firewall is filtering the traffic, because it's the internet control protocol in place. But it's a good rule of thumb to tell you if packages are getting lost, well, something is going on, either physically, or if packages are getting through, then but the traffic is not getting through, then probably a firewall is in place. Another, I guess, common scenario we get issues with the register reading. Some registers can contain, as mentioned previously, they can contain 2 bytes or 32-bit registers. In a way, to get to the actual value, you need to combine those two. Well, how can you combine? I've shown an example there. It's left to right, most important to least important byte in a way. So at the bottom, you'll see the register values from the tool I used previously. This is QMod master, how that's all combined in the tool on the left. What's the actual value that we actually see? In this situation, it's the same because the first register is 0, but that can change. So that's a quick guide, I guess, in troubleshooting that. Of course, there's the general issues that you can have on site. One is obviously data manager software version. Always make sure you have the latest version, so do your firmware upgrades. This applies to the inverters themselves as well. Make sure you have the latest versions. A thing to understand is that issues with the solenoid loop, if you have multiple inverters, can cause inverters not to be readable. Remember, that loop can cause, if you can pull the actual, let's say, a meter, or you get a general response from the data manager, but not from the inverters, that may cause there's a physical situation going on in between inverters as well. If you do implement wireless, there's additional challenges. How is the noise on the line, noise in the air, or noise in the receiver is going to be implemented, any obstructions you want to have, and I guess so we go. At the end, I've put some important document links. These are hyperlinks, so if you click to the link itself, it will take you to the file. Remember, our Fronius Data Manager Modbus has been RTU document or manual. Our latest version is in April this year, so make sure you have a look at that. The API is also important. Info center, good information there. The tools as shared previously, you can be found on links shared there. Okay, we've left some time from some question and feedback. I do apologize if I have tried to push this a bit. This is so we can have a bit of discussion there. Okay.
Okay. Hi everyone, it's Rod here. So yeah, as you can tell, Dimi's gone through a lot of stuff here, a lot of good information. There's probably a lot to take in because it's quite technical. I've tried to answer most of the questions that people have sent through. If there's any questions anybody has, we're just looking at the question box now that you'd like Dimi to maybe go over again, or any questions that he didn't cover in the webinar now, just feel free to shoot some questions into the chat box or question box there.
Again, let me just go back. All right, let's start seeing some questions. TCP IP can also be via Wi-Fi. That's correct. So it's Ethernet, whether that's hardwired, LAN or WLAN, you can choose. Again, be mindful of the wireless challenges.
One here, which, can you share Mbit files for SNMP integration?
Right. I'm going to have to, Albert, yes, I will look that one up and I'll come back to you and answer. Probably today or tomorrow, for sure. Built-in 120 ohm on inverter. We don't have the built-in in the inverter. However, the inverter doesn't have RS485. It's 422, remember? So the 220 ohms is needed when you have a meter or any external control. For the meter itself, the resistor does come in a box and it's integrated in data manager card itself. It's a very small, tiny dip switch on there. So you could use that inverters themselves. You need to use the ending plugs where the loop starts and ends. Don't forget those, the black plugs, terminators. They're critically important for the communication can be established properly. Okay.
Scroll all the way down. Keep going.
Recommend software package to start experimenting with the stop interface in reading and writing. Software package, well, this depends on multiple factors. I have used those two tools I've shared now. Schneider tester I use quite a bit, to be honest, because it's very easy. It's run on and it's easy to work with. QMod Master is also pretty good, as I guess, as well. It's more like, I wouldn't say complex, but it's more settings to be done there. But I wouldn't go beyond these topics. I'm not sure if that answers your question. You're more than welcome to shoot me a more specific one there if you have. Okay, another one. Whenever Modbus is this is a good question. Modbus TCP float versus in plus FL. There's no, I would say you can choose either or, so take a pick. My personal preference is in plus SF. Reason because float, you need to always read the two registers and then convert that into a readable value, because otherwise you might get unrecognizable values there. With in plus SF, it's always integer value, which sometimes scaling factors can be easily troubleshooted on site. For example, if the inverter value is 3,000, you know it's going to be, or 30,000, it's easy to guess it, divided by 10 or 2 or 100, it's still easy to gauge where you're getting at. So my personal preference will always be in plus SF, integer plus scaling factors, but again, always up to you. Okay, I have run a bit through the slides. I do apologize.
Anyone else got a headache? Yeah, no, there's a lot of stuff to cover in here. It's been it's quite a very technical topic, and depending on what you're doing, I guess we base the webinar here on trying to cover some of the things we mainly get in terms of feedback. So we have people in the field who are using PLCs, doing some programming, implementing things into BMS systems. We've kind of gathered up the most kind of things like feedback and issues that people come in the field and incorporate them into the webinar. So There was a question there, I see that from Michael. Is this technology the one that AER is looking at to shut down PV home systems? So not the Modbus thing, and depending on where you've read it in the press, etc., it is a bit of an exaggeration to say that it's shutting down PV systems. There is a lot of, research and a lot of efforts going to interoperability of inverters, so inverter systems, PV systems. So having external control, also mainly look at the monitoring of these devices. The main reason for that is it's going to have to come at some stage, and the alternate to being able to control inverters and the controlling the inverters will only be at times where the network's very constrained. The alternative to that is what will be happening is you have zero export systems on a huge increase of systems going out there. So we are in favor of having more control inverters, but of course that needs to be taken care of. It needs to be done carefully, and the customers need to know what's happening. But the scenario that the AEMO is going to go out and control everything and shut everything down when they want to is a little bit a stretch, but I can understand people's concerns. So
the document for the I guess the register files, it's on your screen there. You can also find the link inside the, I'll go the last page where you actually show the link. So inside the big Fronius Data Manager guides, I'd say guideline PDF, you also find the link there internally as well. Okay, given the inverter is essential, well, technically inverters do use the neutral for measurement purposes. So I guess it's viable, but you wouldn't be able to do it with our snap inverter series because the protection settings, the way they implement it, and the neutral is being used for actual measurement and I guess action on it. So I would guess the answer would be no for that.
So with the new Toros that are coming next year, the larger three-phase inverters, you will be able to use Delta connected, use them as a Delta connected inverter going forward, or a Y connected. Both of those will be possible.
Okay, this went quicker than I guess I was expecting. If
that's good. So don't have any more questions. Maybe we'll leave it open for a few more minutes to see if anyone's coming up with any more. As I said, if there's anything that anyone want us to repeat or something's missed or anything like that, just let us know. And also in general, if something we haven't covered here, feel free to contact us on the solutions email address, which is PV-solutions-Australia. We're just putting it into the chat box at fronius.com. So that'll come to the technical advisors and the application engineers, and we're more than happy to give you some more information on any questions you might have. I think we've covered most of the things there.
Okay. Again, guys, if I can understand, the material is quite a bit. If you have any questions or clarification, don't doubt to contact us. More than happy to clarify. Just the idea was, I guess, to get the grasp of Modbus networking, typical issues, typical implementation, and what can maybe go wrong, I guess, in a way. Reach out and we'll try to help as much as we can.
Yeah. In terms of the slides, a few people have asked that. So there will be, just send us an email to PV-solutions-Australia and ask for the slides. We can send them out, and also we can send you a link to the actual recording of the webinar. It's been recorded, and we can send you that to you just log in and you can just review it again. So Tim's asked a question there. I use the Modbus TCP to read the cumulative kilowatt hours, I'm guessing, or amp hours in the string control or drive from a LG expansion monitoring works well. Okay, so that was more of a statement than a question. Thanks for that, Tim. Okay. All right, good. Well, I think we'll probably leave it at that. Give you guys a couple of minutes back in your day. Really appreciate everyone coming today. As I said, it's quite an intense topic and detailed topic and you've done well to stay on and stay awake. And I hope that some of that sunk in. What was said, the main aim of this was to really really counter or go across some of the main questions we get asked with these things. But yeah, really appreciate all your attendance. Thanks for joining, and if you need any more information, just feel free to get in touch. All right, enjoy the rest of your day, guys.
Thanks, guys. Have a good one. Cheers.